Hi there everybody! Alright, this is going to be a fun one this week. It's kind of loose. We're calling it the Freestyle GIS Lab. What we want you to do is focus on vector data. And I'm going to show you some places you can go get some. You're aware of some of it already. But what we want you to do, and when I'm talking about vector data, of course I'm talking about points, lines, and polygons. So in particular, no elevation data, not working with slope, not working with rasters of any kind. Just keep it focused on vector. What you're going to do is go get some data. You want to make sure it's got some interesting attributes to work with. You're going to use two different geoprocessing tools. So this is stuff like buffering, clipping, intersecting. There's all kinds of cool statistical tools that you can run. There are density tools you can run. You could do a select by location, and I'll go into that in a second. We want you to perform a query on the data, and so this is kind of what I was just talking about, where you can select by attributes, all parcels that are bigger than such and such, or all rivers that start with the letter L, whatever it is, and then you're going to make one formal map demonstrating all the mad skills that you've learned this semester so far, like really well edited scale bars, really well edited legends, really nice layout on the page with alignments, author and data credits, and things like that. And then let's get into the nitty-gritty. So first of all, let's start with data. Where can you get it? This is what I do, free GIS data. And just see what you come up with. Diva GIS is a really great one. There are people, this is a relatively new thing. Robin Wilson has put together this really tight list of contemporary and updated data sources, and you can see that some of the ones that I was going to recommend to you anywhere are already on here. So there's good stuff on here. Remember, avoid elevation data. We want to keep you working with vectors this week. Don't be a hero. Same with the weather and climate data. You might be able to find point files that have precipitation, but most of this is going to be gridded or raster data, and you want to avoid that. So you're going to have to be a little careful. Land cover, if you can find vector data, that's okay, but keep it simple. We haven't gotten into rasters yet, so don't make it hard for yourself. Okay, so take a look at that website. You also obviously can use the website that you should be familiar with, Utah's AGRC. This is an incredibly easy to use website. Scroll all the way down to the bottom and you'll see there's all the different categories down here. Again, avoid elevation stuff because it's raster, but you should find elevation data in contours. There is good vector-based weather or climate data in here. There's all sorts of good stuff. Bioscience has habitats, geoscience has earthquakes, recreation has hiking trails, parks, trailheads, things like that. So yeah, dig in here and just have some fun kind of looking around, I think, is the first goal that we want to set out. Oh great, that's not what I want. Okay, so coming back to the instructions here, let's just, I'll just kind of walk you through it really quick. So what do we mean by go get some data? Here's some ideas. What do we mean by attribute data? You're going to want to look inside the data, open the attribute table, and make sure there's something interesting to work with. Some of the data is kind of bland, and you're going to want to make sure there's something interesting that you can query. So geoprocessing tools, in ARC there's a geoprocessing drop-down menu. Those are just kind of like the top 5 hits, right? It's not the most interesting set of tools, it's just the ones we use the most often. So if you use the ARC toolbox, there's an analysis toolbox that you can expand, and all of the tools inside there work on vector data. There's also spatial analyst tools, line density and point density, which will take vector data and create a raster from it. So it's going a little bit far, but it's at least an option. There's tools like near that allow you to calculate distance between certain features and other features. And then you can do things like clean them up. You're also welcome to digitize. We've had some experience doing that, and that's fine too. Okay, so here's the toolbox icon. If you're not sure what a tool does, use the help. At the bottom of every tool, there's a show help button. Expand that and read about it. You can also Google what the name of the tool is with ArcMap or Esri, and you'll get their help pages that describe things with pictures and it's ridiculous. If you can't find a tool, you don't know what it's called, just Google that. Put it in your own words. ArcMap, I want to cut a polygon using a line. And you will find the answer to your question without even really having to think. Okay, so attributes. This is what I was getting at. Wild turkey habitat. This is a data set with a whole bunch of polygons in it, and when you look at it, they're all colored the same and it just looks really boring. But if you open the attribute table, you can see that there's actual information in there about the seasonality or whether it's crucial or substantial habitat. And you could go in and symbolize your data based on some of these things, or you could go in and select only crucial habitat for the winter and make a subset of data. So these are the things we want you to do. It doesn't have to be any kind of a research project. It doesn't have to be earth-shattering or Nobel Peace Prize winning. Just dig into the attributes, perform a couple of simple queries, run a tool. I just saw a typo here. And then move on. So let's see here. Here's one more example. This is earthquake data. Earthquake epicenters, and if you notice inside, what you're going to get when you display it is just a whole bunch of dots that look the same. But if you look in the attribute table, you'll see that there's magnitude, there's the depth, when it happened. There's all sorts of good stuff in here. So you could symbolize this data, or you could go ahead and select only earthquakes that were greater than magnitude 5, and only earthquakes that happened, within the last 10 years or something like that, right? That'd be performing two different queries. If you don't know what the attributes mean, here's a bunch of stuff. Who knows what gap, DMN, RMS, ERM, ERZ, who knows what those mean? Well, Google it. I had to. I Googled USGS attributes, DMN, RMS, because the Utah AGRC website said that this data came from the USGS. And the very first thing was a metadata folder that came back, and inside of it was a huge description of what everything is. Here's attribute label, RMS. It means root mean square of the travel time residuals after location algorithm iterations. My point is, if you don't know, the information is out there. Go find it. Okay, then you want to perform some kind of query, and I've talked about that a little bit, but remember you can do either attribute or locational queries. So you have done select by location. You've just done this with the pirate data. So push yourself to explore that select by location tool a little bit. The key with the outputs is you're going to want to show me your work. And you don't have to go crazy and write a report up, but you might want to show me a screenshot of your select by location tool so that I can see that it's set up correctly. And then symbolizing numerically or categorically, I just walk you through how you can deal with your symbology here a little bit. And then coming down finally to creating a formal map or a captioned figure. The key is it can't be a screenshot. So I show you a couple examples here, but really the key is make sure you're clearing your selections so that there aren't any, remove any highlighting, and make sure things look clean, that you don't have little dotted lines around things, and that the resolution is really high. So one formal map or a figure that's captioned, but it has to be exported to a high resolution TIFF or something and then put into a Word document. Make sure that the purpose of the map is really clear. So whether you use a title or a caption, make sure that that we understand what you're showing us and where it's located, clear scale, some kind of spatial context, probably a base map. And then if you need a legend to describe your symbology, but you don't always need a legend, so don't make one just to make one. Keep your map really clean and focused. In a Word doc, you're going to want to describe the two tools that you use. There could be more. You need to define what they do and how you used them in your own words. So not just buffer tool, it creates an output file that's a shape around a shape, but what did you use it for? Why did you create the buffer and what did you end up doing with it? And, can I see it in your map? And then also, explain your query or the queries that you did. What were you shooting for and how can you show me that it worked? Does that make sense? And then make sure you include data credits. But really, this isn't a big project. This is just going and grabbing some data. Maybe it's bear habitat. And then you want to find out if there's any bear habitat that's within 5 miles of your house. So go find your house, digitize a point, plop it down there, run a 5-mile buffer, and then clip the bear habitat with your buffer and see if any of it overlaps. And maybe you'll find out that it does, maybe you'll find out that it doesn't. It's that simple. It doesn't have to be this huge thing. So just have fun with it. And if you have any questions, let us know.